overhead squat synopsis. We'll be going over basic concepts, forces, energy, work, and power, and finally hit on some common problems and remedies. The basics will include hand and foot placement, primary joints and muscles, and scapular position. The position of the hands and feet are detrimental to the success of the overhead squat. A wide grip is utilized and feet are placed more than shoulder width apart. This allows for stability and control throughout the entirety of the lift. The joints, to include the glenohumeral, elbow, and wrist, are to remain locked out throughout the entire lift, while the joints of the lower extremity, to include hips, knees, and ankles, will move synergistically with the knees leading the entire movement of the lift. As noted at the bottom of the screen, the feet are slightly turned out to widen the base of the lift. Scapular position in the overhead squat is determined by the isometric contraction of several muscle groups, mainly to include the trapezius, latissimus dorsi, and the rhomboids. The rhomboids are mostly responsible for adducting and rotating the scapula downward to achieve this ultimate position. However, isometric contraction alone cannot ensure that the scapula is properly set. Restrictions to obtaining this position can include the limited movement of the thoracic vertebrae and limited range of motion of the shoulder caused by tight pectoralis muscles. The dangers that can occur if scapular position is not achieved is rotator cuff impingement and or tears. Negative forces at work will determine the required reaction force of the individual to achieve a successful lift. The weight of the bar requires scapular loading to combat compressive forces at hand. Depending on the weight being moved, hands can be placed further apart to achieve further control of the bar. The feet will also turn out more to widen the base of the individual lifting. This will provide stability throughout the entire lift. The individual's mass, coupled with weight, will ultimately determine the reactionary force the individual must overcome. Energy in the overhead squat is primarily transferred kinetically. However, the chemical reactions creating muscle tension at the bottom of the squat generates potential energy to allow the work to be performed. The work performed can be altered by the weight of the bar and the developed strength of the individual. Power is also determined by the weight of the bar, as well as the rate in which it is being moved. Depending on the type of conditioning the individual wishes to achieve, be that endurance, strength, or power, these concepts can be altered to fit the desired result. Common problems include arms that fall forward, lateral movement of the knee, heel lifts, and head tilt towards the floor. Increasing the range of motion of the shoulders through stretching the pectoralis muscles, as well as encouraging thoracic spine mobility, can prevent the arms from falling forward, as the scapula will be properly loaded and contracted. Lateral movement of the knee can be corrected by addressing muscle imbalances. Muscle imbalances may also lead to heel lift, as well as limited ankle dorsiflexion ability. Head tilts can be corrected through postural alignment or remaining cognizant of maintaining a neutral spine.